Okay, this right here is an overview on Repetrel 1.806. Added quite a few features to it. The first one that you'll see is, I think a lot of you are familiar with it, but I'll start with a COM link. This is how you set the port number. The baud rate is 38.4. We will increase that someday in the future, but right now everything's working robustly, so we're going to leave it alone. The ping button allows you to connect to the printer, and it gives you back feedback. It tells you that you've hooked up. If you turn on transmit, it will tell you what's being sent. Right click, you get a whole host of options, but the only one that's important is clear all text. I'll ping it, and now you can see the things that are sent out. And this is basically asking for the soap string from head T12. Here's one on receive, so you're going to see what it looks like when we run. And now you're going to see a big blast of data here. And that data right here is the soap strings coming back from the heads. And if you look over here under control, you'll see there is a head that is loaded. And so we've received back the data about this head and populated it. And it tells you all the different settings and characteristics. We'll get into that in just a moment. Okay, so a little quick trip here is, let's turn off the receive, right click clear. If you're having trouble knowing what kind of G code to use, or want to have an idea what a G code looks like when you click on a button, you can turn on the transmit button here and click on something, and it will show you which command was sent out. So that was the home button. That's a part. And so if you want to see, say, for instance, what happens when we turn a heater on and off, there's your heat on command. Now you'll notice the M911, and that's a little secret, because when you have a parameter that is changeable in real time, meaning that the parameter can be modified during the print, we send an M911 saying this guy gets a high priority like an emergency vehicle, and he goes in front of everybody else that's in the queue, and that way the command will be executed immediately, not 300 instructions later, which is the size of our queue at this time. Okay, so now that you've seen those little tricks, you'll have a lot of fun clicking buttons and seeing what codes come out of them. Now that we've done that, I'm actually prepared to go and show you guys about how to set up the new software. So the first thing I'm going to do is, you'll notice that it says update firmware, print head, or motion controller. Remove the rear cover, plug in the USB cable between the back. It's a little connector, mini connector in the PC407 board, and any USB port that's available on the printer, either on the yoke or on the side of the printer. And then this will show you where the connector is to plug to the PC. You take this little boot run switch here, push it to the left, as it says right there. You push the reset button, and then this will actually pop into green, and that allows you to then select a file and program it. Then you push the button back to the right, hit the reset button right here one more time, and voila, you're done. It takes about a minute or less. If you want to redo the hot heads, then you go ahead and get your ST-Link, and you plug it into a USB port, and like this end goes in the USB port, and the other end goes into your hothead or hotbed controller. Select your file, click program, and in 10 seconds you're done doing the programming. Not so tough. Just follow the instructions and look at the pictures. You'll do just fine. Okay, that covers the firmware upgrade. Now let's go through and let's see what a few things are. Before I go too far on slicing the stuff, let me show you how to set up the print heads. Now this right here, each one of these represents a print head. And the reason this one is in color and not grayed out is there is actually a print head in this printer. And you can walk through its parameters. And this is the way the printer holds its numbers. And so I'm actually going to unfold this. We're going to get rid of this, and I'm going to show you what that looks like. All those deck of cards together. They're right here. So you can see we've made the major interface, which is the control for the heater manual on and off for the motor for just running out material manually so you can clean out your nozzle tip. Manual control of the duty cycle of the fan. You can select the material type, the color of the material. This is for visualization. The nozzle diameter. This also would be the print width. The layer and Z height. This is the default. All of these can be overridden by G code or M code. However, they don't need to be overwritten. If you configure this properly, it makes your slicing adventure much less painful. Here is your print temperature and the minimum acceptable print temperature and the maximum. These two items are not fully implemented below here where we're doing checking yet, but that will come very soon. Up here is your pulses per nanoliter for a ABS that runs about 0.725, 0.75, 0.7 depending on the type of material you have. The feed rate is basically the feed rate over multiplier, and this right here will normally be set to 1.0. If you have some material that's a little out of spec, you can use this to multiply up and down by a multiplier, meaning this is a 1.0 is 100% of calculation. If you have a little too much material, you can drop this down to 95, 90, 80, 85, whatever is appropriate percent. So in that case, it would be 0.85 for 85%. If you wanted 110% of the material, it would be 1.10. All right, so that's your normal override and pulses per nanoliter. Over here is your prime and unprime setup. This is the number of steps that occur during a prime. That means the stepping motor will rapidly move at a fast rate and shove the material out quickly to fill up the nozzle. And then it will wait this many milliseconds. In this case, we're showing 20, but that's not a good number. The better number right now is 100. As a matter of fact, I can go ahead and set some of these things up right now so that they look better. That's a good idea. And we're finding out that this is for an MK1 looking about 300. And we're finding out that this also can be just about exactly the same. And we're finding out that the faster that these are run, the better off we are. So we're running that at 10,000, which right now is the maximum amount I'm allowing. The motors can actually spin faster, but we're making sure we're getting all those pulses at this rate, so we'll leave it alone. And this is your unprime numbers. So if you configure your hothead just like this, and again, it will not look like this when you're looking at it. These are a deck of cards that when you hit the arrow button up here, and I will bring it back and show you. So as I hit the arrow button, it walks through the deck of cards. And when you get to the last one, it says flash. We'll get to that in a second. Okay. So next to your offsets. Now these are important. If you're going to do multiple material prints, one of your heads will be the anchor head, and he'll have no offset to him. So you can leave them zeros. Your other heads will be relative offset. Typically it's 35 or 70 or 105 millimeters. But to really get right on the money, it might be 35.12 millimeters. And to do that, we have a little video we'll make later on, but basically you can jog the motor back and forth, and I'll show you a little bit how to do that. Well, I'll do it right now. So suppose I line up head number 1 over one of the lines on the grid. Then I want to idle this. So I'm out at park position, so you'll notice that I move over a millimeter and that X goes up. Couple pluses, couple minuses. So let's go ahead and run over to, oh, we're too far. We're going to bring it back. And now the other head, the next one adjacent that I want to coordinate the move with, should be right over. But I'm going to say, you know, it's just a little bit off. I want a really good control, and 1 millimeter doesn't cut it. So click the Fine Move button, and now you can move it 0.05 millimeters at a time. So that's pretty good because that's 2/1000ths of an inch. And if you can eyeball 2/1000ths of an inch, well, you're a better man than me. Anyway, there you go. Now suppose you go, oh, I forgot to zero it. Just click on the label here, and it re-zeroes the button, and now everything is a relative measurement from where you just came from. Off with the fine. There goes 10 millimeters at a time, or 100. There you go. Okay, so that hopefully will give you an idea on how to use the X and Y commands to make these things look better in their relative. So now that that's done, let's go back over to the next deck in the cards. And if you click on this button, it will actually say that this head is the head that's current and apply these offsets, and it will actually move. So you can get two of these guys, and I will show you, get two heads that are live, and you can get to this screen right here, and you can click on one, and then you can click on the other. And when you do that, they will go back and forth over that line you selected, and you will have a good time, because that way you can make sure that your offset really lines up well by going back and forth, and just double, triple checking that you're happy with it. Anyway, that's another little secret. And the next one is allowing you to set the model, the RTD, the motor current, and step. Do not worry about this information. It's not being utilized yet. It will be used in future releases, and so I encourage you greatly to accurately set it up, and I will show you what that looks like. So we go to the next one here. You'll notice there's a pop-up. You can now tell it all the different things it might be. In this case, I'm working with an EMO 25. The RTD does not matter, but I'm going to leave it at 50K. Motor current would normally be high for that. We want as much torque as possible when working with plasticine. And it's 1/16 step mode. The next thing is now that you get everything all put together, you would right-click on the flash. If you're using a touchscreen, just put your finger down and hold it there until a circle forms. That's the same thing as a right-click, and then up will pop this nice window. And it says, warning, this will change the printhead default settings. Are you sure? Yes, I am. And now I just programmed it. It's done. You can do this about 20 to 50,000 times before you wear out the circuit board's memory. You're probably not going to do that anytime soon. Let's see, if you did it 10 times a day, that would mean you'd have about, I don't know, a lot. 1,800. You might have 10 years before you wear out the board. I'm pretty sure it'll wear itself out by then. Anyway, that would be if you did it 10 times a day. And so that covers the initial setup of your printhead. Now, at this moment, I'm going to stop, and that gives you a little idea. And I'm going to clip this off so we have one video, and then we'll start another one.